take a look here now at example number 4. We're going to try to use all the different ideas of this section to help tackle the questions here. At any town college, 100 students were randomly surveyed, and it was found that out of these 100 students, 55 owned a bicycle, 30 owned a car, and 10 students owned both. Fill in the following table with information from this study. Okay, notice what I've given us here is a table that is unbelievably similar to the table that we had back here on example 2. The one that we had here just had a lot more kind of rows associated with it. But now we have something very, very simple in this table. So keep in mind that these outside rows here are going to be forming totals. And ultimately then here in the corner should be our grand total number of people that participated in this survey. Well, that would be 100 individuals. Let's see if we can find where to put the rest of this information. We were told that 55 total students owned a bicycle. So here's owning a bike. And so where would the total number of people go that own a bike? Well, that should be over here in total. So 55 people own a bike. Notice that the moment that I fill this in, I can start to fill in some other information. Because if 55 people own a bike, and there are 100 people total, how many people don't own a bike? Well, that's got to be 45, right? Because this has to add up to 100. Okay, not much more I can fill in. We also know, though, that 30 students own a car. So that's the total for students that own a car. And so if 30 do, then 70 don't. I also know that 10 students own a car and own a bike at the same time, and that would be a number that lands right here. Notice now a chain reaction can kind of start, where I can start to fill in a lot of these other values. I know that if there are car owners that do and don't own bikes, the total of those have to add to 30. Same thing going across. 10 plus 45 makes 55, and 20 plus 25 makes 45. And notice I can even double check coming down here. 45 plus 25 does indeed make 70. So this is good. I have my table filled out. And occasionally on some worksheets and on different assessments, I might ask you to fill out a table very similarly, and you should be able to do so with the given information. Notice though, once I have this, I can go ahead and start to label each of my different categories, maybe with some symbols. So maybe like for own a car, I'll do C. Over here, for doesn't own a car, I could do either something like C complement, because that's doesn't own, not own a car. And so I could make use of that complement notation, or I could come up with an entirely different letter. Now I'm going to stick with this complement notation because I think it's important to get used to using that. Also be aware though that you may see from time to time people, instead of using a little C up top, they'll use a tick mark, and that means the same thing. I like to make students aware of that just in case you're seeing some things in other videos or other textbooks or talking to some friends or something like that. You may see them use that notation. It means the exact same thing. Now, on the side here, then, I'm going to go ahead and I'm going to use B for bike, and I'm going to use B complement for doesn't own a bike. Let's see then if I can answer some of these questions down below. Now, actually, I would encourage you, instead of just watching me work through these solutions, why don't you go ahead right now, pause the video, and see if you can try to work through these solutions on your own. I, again, would ask you to start every single problem by writing out some probability notation, then using a formula if necessary, and ultimately arriving at a final answer. So go ahead, hit pause, give yourself a chance to practice right now, and when you hit unpause, you'll see me work through the solutions. Okay, so let's see what we got here. What is the probability that a student selected at random from this group does not own a bicycle? So that's probability of B complement. Well, notice this is actually super easy. I already know the total number of people that do not own a bicycle. That's 45 out of 100. So my answer here is 45%. Done. Next question. What is the probability that a student selected at random from this group owns a car, C, but does not own a bike? Well, notice I don't care, or I don't want just one of those to be true. I want both of those things to be true. And so that's an indication that I'm looking for an and. I want the person to own a car, but not own a bike. So I'm looking for, out of these 100 people, where are the people that meet both of these descriptions? Well, let's see. If I own a car and don't own a bike, there are 20 people that meet that description. So I have an answer of 20%. If we keep going, what is the probability that a student selected at random from this group owns either a car or a bicycle or both? Notice that when I have this or both here, that is covered by the original word or, which allows me to say I'm happy if somebody meets one of the descriptions, and if they meet both of them, that's also okay. So immediately I'm going to think to myself, hey, wait a minute. We had rules for or that we talked about previously in this section. One of the things I would want to do is to figure out, is it possible that someone could own a car and a bike at the same time? Well, looks like it. There are 10 people that can do that. So I'm going to use that general addition rule, which said find the probability of C, find the probability of B, and then subtract the probability of C and B at the same time. So let's see what we got. Probability of C. So that's probability that people own a car. Well, there are 30 car owners out of 100. So that's going to be 30 out of 100. Bike owners. Probability that I find someone who owns a bike. Well, that's 55 total people own a bike out of 100. Now I want to subtract from that the number of people that own a car and a bike. And I remember from the beginning that was only 10 people. As a grand total, that's 75 people out of 100, and that gives me 75%. Well, there we go. Next question. What's the probability that a student selected at random from this group owns neither a car nor a bike? Do I want both those things to happen at the same time? Do I need both of those things to be true about the person? Yes. So I want no car and I want no bike. I want both of those at the same time. That's always the word and. And again, ands are so easy to calculate because you can just go look in your table and find the overlap. Where are these people that don't own cars and don't own bikes? Well, don't own cars, don't own bikes. It looks like there's 25 people there total. So this is 25 people out of 100. That's 25%. Okay, let's take a look at the very last one. What is the probability that a student selected at random from this group owns a bike or doesn't own a car? All right, well, let's see. Is it possible that there's an overlap here? Could it be the case that someone could own a bike and not have a car at the same time? Well, yeah, I mean, it looks like that's these people. They exist. It's possible to do this. So I'm going to set this up just like we did before with this general addition rule. I'll do the probability of each thing and then just subtract the overlap. So let's see. Probability that someone owns a bike. I think there were 55 bike owners out of the 100. Probability that someone doesn't own a car? Let's see. There are 70 non-car owners. And then I want to subtract from that the number of people that ended up with owning bikes and not owning cars. We said that was 45 individuals. So if I put all of this together, I'll notice that this gives me a total of 80 individuals out of 100, or 80%. Hopefully you were able to get the same answers if you tried this on your own. And if not, don't stress too much about it. This is your first time maybe trying something like this. Go to the worksheets and continue to practice these ideas. Hopefully the idea of a complement here doesn't seem too terribly tricky. In fact, on this example, it might even seem kind of worthless. However, in the next example, in example 5, we'll see how we can actually use complements to our advantage to really shortcut a bunch of work for us.